Welcome back to Maths in an Empty Classroom with me, Mr. Southern. This is part 3 of the lesson on integration by substitution, and in this video I'll be taking you through an example with some trigonometric identities. Okay, so here we are. We're going to be integrating between 0 and 1/2 the function 1 over 1 minus x squared to the power of 3 over 2 with respect to x. And to do that, we're going to be using the substitution x equals sine theta. So with questions like this, you've got to be really hot on your trig identities, and having a working knowledge of exact values is really, really useful as well. So the first thing that I'm going to do with questions like this, where there's going to be quite a lot going on, is I'm going to change these limits, because you'll remember in the previous video we identified that these here are x limits because we're integrating in terms of x, and we don't want x limits. We're going to want our limits to be in terms of theta, because that's what we're going to swap the integral to using the substitution. So the first thing that I'm going to do is change the limits by saying if x equals 1/2, that means that sine theta equals 1/2, which means that theta would be pi over 6. So knowledge of exact values, and remember everything that you do with calculus, with trig, is in radians mode, not degrees. So pi over 6, not 30. The other limit is x equals 0. So we would be saying that sine theta equals 0 and solving, and that would mean that theta equals 0 is the lower limit of integration. So I'm just going to highlight those two bits so that I can use those when I come to do my substitution. Okay, x equals sine theta, so we can see that x is going to go in there, but we're going to have to deal with this dx as well. So what we're going to do is we're going to say that x is equal to sine theta, differentiate x in terms of theta to get dx d theta equals cos theta, and then because we're looking to swap this dx, we're going to write that dx equals cos theta d theta. And that's different to the previous ones because we had to take the reciprocal because of what we were looking to swap. This time, because the substitution is given in terms of, with x as the subject, I should say, when we differentiate, we get dx d theta, so we don't have to play around with the reciprocals. Okay, so here we go. Let's rewrite this integral then with everything substituted. So instead of 0 and 1/2, I'm going to be writing my limits in terms of theta, which is 0 and pi over 6. 1 over. Now instead of 1 minus x squared, because x is sine theta, I'm going to be writing 1 minus sine squared theta, and that should be screaming a trig identity at you. That's to the power of 3 over 2, so that bit hasn't changed. But dx is now swapped, so I'm going to put multiplied by cos theta d theta. So this is what our integral has now become. Limits are changed, sine theta's gone in for x, cos theta's gone in for dx. And now I need to look at how I can manipulate this. So that trig identity that I said to you there was screaming at you. What is it? 1 minus sine squared theta, what's that the same as? Cos squared theta. And that's really, really nice, because if I change that to be cos squared theta, and that is to the power of 3 over 2, have a think about what power 3 over 2 means. Okay. So power 3 over 2, square root, and then cube. So the square root of cos squared is going to be cos, cubed is going to be cos cubed. So I'm going to now write that as 1 over cos theta cubed multiplied by cos theta d theta. Still between pi over 6 and 0. Now, I've got cos theta cubed, or cos cubed theta, on the denominator. I'm multiplying that by cos theta, so it's possible to now cancel that cos theta with one of those and cancel it down to cos squared. So now I've got 1 over cos theta squared with respect to theta. What's 1 over cos squared theta the same as? Think about your reciprocal trig identities. Sec squared theta. Right, so integrating between 0 and pi over 6, 1 over cos squared, which is now sec squared theta. And we're doing that with respect to theta. And now we have something that we can integrate. It's in the formula book what sec squared theta integrates to. It's worth having a working knowledge of it though. The integral of sec squared theta is tan theta. So what this is now going to come out as is tan theta between our limits of pi over 6 and 0. So substituting in, finding the difference, we'll evaluate this integral. So we're going to have tan of pi over 6, take away tan of 0. Tan of pi over 6 is root 3 over 3. Tan of 0 is 0. So the value of this integral is going to come out as root 3 over 3. So there we go. We started with something that looked quite complicated with a trig substitution, but with our knowledge of trig identities, differentiating trig, we were able to find something that cancelled nicely and ended up turning into something that we knew how to integrate. And that's the kind of thing you should be looking to spot with any integration by substitution involving trig. There's going to be identities all over the place, and the more fluent you are with them, the easier you'll find it to do questions like this. Okay, one more to go. See me in the next video.